Hello, I'm Dr. Zia Tahir. This video tutorial is solution to problem 4 by 11 of Engineering Mechanics Statics 9th edition by J.L. Meriam. Statement of the problem is determine the forces in member AB, BC and BD of loaded truss AB, BC and BD. So in all linear members. But there are two curved member AD and DC, and here is a fact about that curved member. In a pin joint truss, a curved member behave as two force member. So its effect is the same as straight member. So therefore, it transmit only axial force, either tension or compression, tangent to the curve at a joint. So for analysis, so AD, which is a curved member, so it can be assumed as a straight member AD and a straight member DC. So to find member forces, the first step is select a joint with at least one known force and two or less than unknowns. So there is only one known force at joint D, but at joint D there are three member forces which are unknown. So we cannot start with joint D. So now, as no joint satisfies this condition, so need to find support reactions first. So to find reaction, need to draw a free body diagram of entire structure by ignoring internal members and replacing supports with reaction. So A is a pin support, so it has two reaction, one in horizontal and one is vertical. And C is a roller support, so it will have one reaction perpendicular to the surface. And then assume convenient direction of all reaction. It doesn't make any difference at which direction of reaction you are going to assume, and after applying equilibrium you can solve for the reaction, and a positive result confirm that whatever is the chosen direction at the start, so that is. So to find reaction, free body diagram is drawn, and ax and ay, I have choose random direction of ax, ay and cy, and the distance from a to c is 2r and b to d is r. So now I can find reactions. So to find reaction, I'll use that sigma m first equal to 0. So sigma m moment about a point is equal to 0. So the moment point, I need to select a point which has maximum number of unknowns. So point A I am going to select here. So for point A, now the forces are Cy, so that is the line of action of Cy which is vertically upward, and the distance of from line of action of Cy to A is 2r, and Cy is trying to rotate AC in anti-clockwise direction. Then the other force is L, so the line of action of L is there, that is the line of action of L, and the perpendicular distance from line of action of L to point A, so that distance is equal to R. So from the line of action, so now that is actually L is going to act here, and it is trying to rotate that perpendicular distance into clockwise direction. Okay, so then assuming anti-clockwise as positive and clockwise as negative, so due to Cy, so moment due to Cy is Cy times by 2r, and then minus L times r is equal to 0. So 2Cyr is equal to Lr, and Cy comes as L over 2. So that is Cy L over 2. So the next one I can apply here, sigma fx equal to 0. And for sigma fx equal to 0, so there is only one force acting in horizontal direction. One known is L and one reaction is A. So Ax is positive, then plus L is equal to 0 because both are towards right or towards positive x-axis. So Ax comes as minus L. And then sigma Fy I am going to apply now. So in the vertical direction, there are only reactions. No load is in vertical direction because it's horizontal. So AY plus CY is equal to 0. So AY is equal to minus CY and A minus CY. So CY is L over 2. So that is L over 2. So now I have chosen random direction of the reactions and then solve the reaction. A positive result confirms the assumed direction is correct. So for AX first, AX, its answer is negative. So it's mean that its chosen direction which was towards right. So that is need to be opposite. So AY is towards left and then AX is L and towards left and then AY is minus L over 2. So that is L over 2. So I have chosen its direction upward. So it must be downward. And then CY, I have chosen its direction upward. So it is positive. So as it is positive, so it's mean that chosen direction which I have used is appropriate. So that is L over 2 in upward direction. So now I have find all the reactions. So then I can put that reactions on the truss. So once again now once the reactions are found and then now need to select a joint with at least one unknown force. So I can select C and I can select A. Okay, so it doesn't make any difference that which one I am going to select. Okay, so let's say I am going to select joint A and remember that AD using the fact here, I need to consider that as a straight line. So then isolate the joint. So I'm going to isolate joint A. So after isolating that joint A, so then I can draw a free body diagram. So that's a free body diagram of joint A. So AB, I have assumed that as intention and AD, that is acting like just a line connecting A to D. So when it is being connected, so a triangle ABD is formed. In that triangle, side AB and side BD are the same. So when two sides are same in a rectangle triangle, so the other than 90-degree angle, so all both angles are 45. So AD makes an angle 45. So then the next one, resolve inclined members into components. So then AD can be resolved into two components. One is ADX, ADY, sorry, and the other one is ADX. So then I can apply conditions of equilibrium to this joint A. So to apply conditions of equilibrium at joint A, so in horizontal direction, there are two unknown AB and ADX. In vertical direction, there is only one unknown ADY. So I'll go for sigma Fy equal to 0 first. So sigma Fy is equal to 0. So ADY is acting vertically upward. So that is plus ADY. And that AY is acting vertically downward. So minus L over 2 is equal to 0. So ADY is then AD times by cosine. So it is sine 45. So either you can use angle theta or you can use a small triangle. So that is L over 2 and then AD is equal to L over 2 times by sine 45. So the answer is, so AD is L over 2 times sine 45 is going to divide here. So then 1 over 2 times 1 over sine 45 is root 2 over 2L. So once it's done, then I can apply sigma Fx equal to 0. So for sigma Fx, the one known force is the reaction which is towards negative x-axis, so minus L plus AB, and the other one is plus ADX is equal to 0. So then AB is equal to ADX plus minus ADX plus L. So this is then AD, I already have that. So root 2 over 2L into cosine 45 plus L. So need to write exact values there. So now AB is After doing the calculation, minus half L plus L, so that is half L. So now AD is positive, and then AB is also positive. So using the convention there, so interpret the results. The unknown member result of unknown member force, a positive value indicate tension and a negative that indicates compression. So then here AB is half. So I'm going to write the answer. So AB is equal to half L, and that is in tension, and AD is root 2 over 2L, and that is also tension. So I'm going to show that on the truss. So now AB is in tension with L over 2 magnitude, and AD is also tension with root 2 over 2 in magnitude. So now the step 4 is repeat step 1 to step 3 for adjacent joint. So from A, then I can go either at B or at D. So I am going to select B, and then I'm going to isolate B, because at B next two unknown BD and BC are unknown, and one now AB I have just found that it is L over 2. So now AB is L over 2 in tension, and then unknown member forces BD and BC, I have assumed them in tension both. And then I can resolve inclined member. So there is no inclined member. So because that is which is shown here, that is the R radius. So then I can apply conditions of equilibrium to find unknowns. Joint B, I can apply sigma fx equal to 0, and there are one unknown BC, which is towards right, is positive, and minus AB, it is L over 2 is equal to 0. So then BC is L over 2, and then I can apply sigma Fy equal to 0. So for that sigma Fy equal to 0, so there is only one force BD which is equal to 0. So then I can write the answer. BC is positive, so it is L over 2 in tension, and then BD is a zero member force. Okay, so then I can plot that BC and BD on the truss. So then BC is in tension, and that is L over 2, and then BD is equal to 0. So I have to find only these three members. So AB and BC, they are equal. They are equal to L by 2 in tension, and BD is equal to 0. So that whole truss is now solved. So I hope that you find this uh, solution helpful. Thank you very much for watching.